Alright, last one of these. We are told that the cosecant of theta equals 2, which means cosecant is hypotenuse divided by the opposite side. Think of it as a fraction, 2 over 1. So we get 2, and we get 1, and we get 2 squared minus 1 squared equals b squared, which means 4 minus 1 equals b squared, which means 3 equals b squared, which means the square root of 3 equals b. Boop, 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 boop. Hey, 1, root 3, and 2. Do you recognize this triangle yet? I hope you do. Let's write down the sign for this triangle, and then maybe you'll realize what that angle has to be. Well, sine is the reciprocal of cosecant, so if cosecant is 2, then sine is 1 over 2. Hey, sine of theta equals 1 half. Whoa, that means this is a 30, 60, 90 triangle, which is kind of cool. Cotan squared of theta, but you don't even need to know it's 30, 60, 90 to do this. I was just pointing that out that we did know that, which is cool. Cotan squared of theta is the same as cotan of theta all squared. So what is cotan of theta? Well, cotan is adjacent the square root of 3 divided by the opposite side of 1. But we are squaring it because it is cotan squared. Therefore, I get 3, which is kind of cool. Alright, secant of 90 minus theta. I can use my co-function identities to rewrite that as cosecant of theta, which is nice. Because cosecant of theta, I already know, is 2. Haha, it was given to me. That's how I started this whole thing. So finally, secant squared of theta, which means secant of theta squared, equals secant, which is hypotenuse, divided by the adjacent side, h over a. Oops, but don't write a. Silly person. Write square root of 3. But it's secant squared, so square that thing. Square the top, 4. Square the bottom, 3. So we get 4/3.